Okay, let's take a look at another example of how to use the big three kinematic equations to solve some problems involving rising and falling objects under the influence of gravity. Here we go, example 2. If you dropped a baseball from the top of a high building, how fast would it be going after 3 seconds of perfect free fall? So that's just dropping a baseball. But then B, if instead you threw the ball straight up from the top of the building with a velocity of 30 meters per second, how fast would it be going after 3 seconds? And then question C, what if you threw it straight down at 30 meters per second? Then how fast would it be going after 3 seconds? So I've gone ahead and drawn pictures of these. Here's situations A, B, and C. In situation A over here, we're just dropping an object from the top of the building. Okay, that means the initial velocity is 0. In situation B, now we're throwing the ball upwards at 30 meters per second, letting it come back down. And then in situation C over here, we are throwing the ball downwards with an initial velocity of 30 meters per second. Okay? So let's try the first question. If you dropped it, how fast would it be going after 3 seconds? So we're going to use equation 2. The final velocity is the initial velocity plus the acceleration times time. If you drop it, the initial velocity is 0. So I can go ahead and plug that in here. It's going to be accelerating at negative 9.8 meters per second squared because it's in free fall, and it's going to do that for 3 seconds. So it's just going to be negative 29.4 meters per second. That would be its velocity here, v final, just before hitting the ground 3 seconds later. All right, question B, if instead you threw the ball straight up, then how fast would it be going after 3 seconds? Okay, same process, but now we have an initial velocity. Now the initial velocity is 30 meters per second. And then against that initial velocity, gravity is going to be acting for 3 seconds. Okay, so now we end up getting 0.6 meters per second. Okay, so that's going to be very near the peak because it's almost 0. So in the second situation, our v final somewhere up in here while the ball is still rising. The final velocity is 0.6 meters per second. How do I know that the ball is still rising? Because this is a positive number. If the ball had passed the peak and was starting to fall down, I would have gotten a negative number. Question C, what if you threw it straight down at 30 meters per second? Okay, same setup. Initial velocity plus acceleration times time. Now my initial velocity is negative 30. So I realize I didn't say that here, but I have to be smarter than the question and say if I'm throwing it down, then it actually has a negative velocity. So negative 30 meters per second plus that acceleration multiplied by the 3 seconds. And I just realized I forgot to put the square in the previous one. So now this gives us negative 59.4 meters per second. So going quite fast in this third scenario. So that would be the final velocity here.